Good day, everyone. I am Ma'am Shirley, and welcome to our Statistics and Probability class. For this discussion, we will be having the normal distribution. At the end of the discussion, we are expected to first, illustrate a normal random variable and its characteristics. Second, identify regions under the normal curve corresponding to different standard normal values. But before we start with our discussion, let us first have a review of our previous lessons, which are also essential to our next lesson. Read and answer each question before the time is up. Are you ready? Let's go. Question number 1. Which measure of central tendency is also called average? A. Mean. B. Median. C. Mode. Or D. Range. 5 seconds. Go. Time is up. The correct answer is A. Mean. Second question. Which of the following Greek letters is used to represent population mean? A. Uppercase sigma. B. Lowercase sigma. C. Mu. Or D. Delta. 5 seconds. Go. Time is up. The correct answer is C. Mu. Third question. Which of the following is a continuous variable? A. Number of COVID survivors in Bataan. B. Temperature of people entering a mall. C. Population of employed residents in a barangay. Or D. Number of brand of vaccines available. Again, 5 seconds. Go. Time is up. The correct answer is B. Temperature of people entering a mall. Fourth question. What is the diagram representing a frequency distribution characterized by rectangles? A. Histogram. B. Bar graph. C. Line graph. Or D. Pie chart. 5 seconds. Go. Time is up. The correct answer is A. Histogram. Last, fifth and last question. Which of the following is a measure of dispersion? A. Mean. B. Mode. C. Standard deviation. Or D. Frequency. 5 seconds. Go. Time is up. The correct answer is C. Standard deviation. Good job. What's your score? I hope through the short review, you were able to recall important concepts on statistics. Now, I want you to take a look at the following pictures. Are you familiar with this place? Correct. It is a famous landmark in our province, the Mount Samat, found in the municipality of Pilar. This shot is from the Duha Trail, another place to go for nature lovers, especially bikers, found in the nearby municipality of Orion. From this shot, we can see the slope of the mountains in the nearby hills that complements the view. Have you been to this place? We are free to visit this, but always take note of the health protocols to make sure of the safety of everyone. Next, a flower that is native to America but grows abundantly in our country. It got its name from its color and shape. You know what it is? You got it right. It's a yellow bell. Next is a common icon we can see whenever we're browsing videos on social media or on different online platforms. These are notification bells that you click for you to be updated of the recent uploads of a certain channel or influencers. What is common among these pictures? Correct, it's their shapes. For our lesson, we will encounter a curve that is similar to this shape. Guess what it is called? You've got it right. It's a bell curve. Its name is obtained, of course, from its shape. It is also called a normal or a Gaussian curve. The normal curve represents many common variables we encounter daily, such as height, weight, scores, length, or temperature. Let us have height as an example. For Filipinos, the average adult height for male is 163 centimeters. Of course, there are people who may have a height more than 163 centimeters, or some may be shorter than this value. But let's say we recorded the height of a number of males. Most of them will probably fall under the average height, which is 163 centimeters. If we will be showing that using a graph, it may look like this. The frequencies will concentrate on the center where the average value can be found. For further understanding of the concepts of the normal curve, let us enumerate its properties. First, it is a bell-shaped curve. Next, the mean is equal to the median and equal to the mode. Third, the tails or ends are asymptotic relative to the horizontal axis, meaning the tails will approach the horizontal axis but will not touch it or intersect it. Next, the total area in the normal distribution under the curve is equal to 1 or 100%. It is also symmetrical about the mean. This is also where the highest point of the curve appears. It depends on two factors, the mean and the standard deviation. The mean determines the center of the graph, and the standard deviation determines its height and width. So how are we going to illustrate a normal distribution using a normal curve? So the normal curve may be subdivided into standard deviations, at least 3 units to the left and 3 units to the right of the vertical line. You may ask, Ma'am, can we not extend it to 4 or 5 units on both sides? The answer is yes, you may. But it will not be advisable since the values on the tails are so small that it will not be necessary. Remember, the tails are asymptotic to the x-axis, meaning it will just keep on approaching the axis but it will never intersect. I hope this is clear to you. Let us have more examples. Let's say we have a given distribution wherein the value of the mean is 8 and the value of the standard deviation is 2. So we're going to start by drawing the axis. Since we know that the mean is at the center of the curve, we're going to write 8 at the center. And then we're going to proceed to the values to the left by subtracting the value of the standard deviation, which is 2, from our given value of mean, which is 8. So that will be 8 minus 2, that will give us 6, minus 2, that will be 4, and then minus 2 again, and that will give us 2. After that, we're going to proceed to the right side. This time, we are going to add 2 to the value of the mean. So that will be 8 plus 2, that will give us 10, plus 2, that will be 12, and another 2, giving us 14. So we're going to finish our illustration by drawing a smooth curve. And that will be the normal curve representing the distribution with a mean of 8 and a standard deviation of 2. Now let's see what will happen if we will have a different value for the mean, but with the same standard deviation rather. Let's say the mean is equal to 10 and we have the same value for the standard deviation, which is 2. Since the value of the standard deviation is the same, it means that the width of the curve will be the same or remain unchanged. But since the mean is equal to 10, the center of the curve will now be at 10, thus giving us this corresponding normal curve. So the center will be at 10, and then since the value of our standard deviation is the same, we have here 2, so the distance from the mean will still be 2. So that will be from 10, which is our center, we will have 8, 6, and 4. And then to the right side, we're going to have 12, 14, and then we're going to add another one, which is 16. So remember, if we're going to draw our normal curve, we're going to have 3 values to the left and 3 values to the right. So giving us this normal curve. In our examples, the values on the axis vary with every condition. However, these values on our axis can be converted into standard scores known as z-values, wherein, just like in a number line, 0 is at the middle, while negative values can be found on the left and positive values on the right. Using a z-table, areas under the normal curve can be found. The conversion of values will be discussed in the next video lesson. For now, let us first be familiarized with the empirical rule, which lets us identify the areas under the normal curve in between integral values. When we say integral values, this means whole, no decimals or fractions. So the following is the empirical rule. First, for z is equal to -1 and z is equal to +1, the area between these two values is approximately 68.3%. Since we know that the curve is symmetrical, it gives us 34.15% on the left side and another 34.15% on the other side. Second, for z values between -2 and +2, the area under the normal curve is approximately 95.4%. The same with the first one, it gives us 47.7% on the left side and another 47.7% on the other side. And lastly, for z values between -3 and +3, the area is approximately 99.7%. Also, that will be 49.85% on the left side and 49.85% on the right side. Okay, so let us proceed to more illustrative examples. Construct a normal curve for a distribution with a mean of 60 and a standard deviation of 5. Then, find the following probabilities. Number 1, the probability wherein x is greater than 55 but less than 65. Number 2, the probability that x is less than 60. Number 3, probability that x is greater than 50. And number 4, the probability where x is greater than 45 but less than 65. Okay, so let's start with drawing the bell curve and putting all the markings. Since the mean is at the center and the value of our mean in the given example is 60, we are going to write 60 in the middle. Then, since the standard deviation is 5, it means that the distance between each point is 5. So we're going to do that again by subtracting 5 from 60 for the values to the left And that will give us 60 minus 5, that is 55, minus 5, that is 50, and another minus 5, and that will give us 45. And then for the right side, we're going to add 5 to 60. So we will have 60 plus 5, 65. 65 plus 5, that will be 70. And 70 plus 5 will be 75. So we will be using this normal curve to find the given probabilities in our example. So using this curve, let us start with the first one. So for the first probability, we have here probability wherein x is greater than 55 but less than 65. So to do that, let us identify the endpoints. So we have here 55 and 65. So that will be this area. So based on the empirical rule, as we can see here in our discussion a while ago, this area will be equivalent to -1 and +1, which is approximately 68.3%. Therefore, our answer for number 1 is 68.3%, or in decimals, that will be 0.6830. Second example, again, we will be using the same normal curve. So the probability that x is less than 60. So as you can see here, we have one endpoint, which is 60. So since we are dealing with the values less than 60, that will be from 60 going to the left. By looking at our example here, we can see that we are dealing with half of the curve. So we can easily say that this one will be 50% of the distribution, or that will be 0.5. Okay, so let us have the third example. For the third example, we have here the probability that x is greater than 50. Again, we have here one endpoint, which is 50. And then it says here, values greater than 50. So that will be from 50 all the way to the right side. Based on the empirical rule, 50 here corresponds to 2 inflection points from the center, which is equivalent to 47.7%. We also covered here half of the curve, which is this part on the right side. And since it is half, so that will be 50% of the distribution. So for us to identify or to solve for the indicated probability in our example, all we have to do is just add these two values, and that will give us 47.7% plus 50%, which is equal to 97.7%, or 0.977. Okay, it's your turn now. Let's check what you've learned. Read the instructions and write your answer on your answer sheet. Try this problem. You may pause this video while answering. A continuous random variable x is normally distributed with a mean of 25.1 and a standard deviation of 3.2. Illustrate a normal curve and find the probability of x is greater than 21.9 at less than 31.5. Good job! Now, let us have more exercises. Draw a smiling face if the statement is correct and a sad face if not. Number 1. A normal curve is also called a Bell or Gaussian curve. Number 2. The standard deviation determines the center of the curve. Number 3. A bigger standard deviation means a wider curve. Number 4. The curve is asymptotic about the mean. Number 5. The empirical rule implies that about 68.4% of the distribution falls between one z-value from the left to one z-value to the right of the mean. Great! Now, self-check your activity by referring to these answer keys. You are now ready to answer the activities in your learning activity sheets. Go ahead and do your best. Thank you for watching. Remember, in this new normal, embrace your normal self. Goodbye, and see you in the next video. Stay safe, everyone.